Welcome to everyone that's joining virtually, and special welcome to those of you that braved the weather today to come in person. So I'm kicking off our database Dev Lab event. And what I want to talk about today is what we're calling our App Simple effort, which we think is the future of data-centric app dev. I'm going to start by talking about kind of our overall approach and strategy. And then I'm going to talk specifically about some of the new technologies that we're going to be delivering this year to make application development dramatically simpler. So first of all, overall strategy, traditionally we had an OLTP relational database and a data warehouse relational database. But things have changed. So now modern app dev uses a whole new generation of data technologies, and they're all about delivering a compelling experience and more value. So in addition to relational, we now have documents like JSON and XML. We have spatial. We have text. We have, in addition to data warehousing, machine learning, big deal, graph technologies, lake houses, microservices, another big deal, geo-distributed, and data sovereignty, IoT, and blockchain. It's a whole slew of new technologies that have been introduced into data management. And as a developer, the breadth and depth of these technologies actually makes everyone's life harder. So developing an app, now you have to incorporate all these technologies that you didn't have to even know about before. And there's kind of two approaches to incorporating these technologies. There's the specialized database approach, where you use a specialized database for each of these needs. And the specialized database is chosen because it excels at a specific type of workload or data type. With this approach, every app requires distributed execution and data movement. It's complicated. Developers have to focus on integrating all these different data systems. Now, we have a different vision. Oracle's vision is to make modern apps and analytics easy to develop and run for all use cases at any scale. And the way we do this is what we call a complete and simple platform for all database management needs. So by complete, we talk about a converged database. What converged database means is a database that has complete support for all the modern data types and workloads and development styles, and it's completely consistent, simple, and available. So all the operational stuff is taken care of. And by simple, we mean an autonomous database, a database that runs itself with little or no operations or administration. So what our autonomous database is, that converged database with all the functionality delivered on our world's best database platform, Exadata, in the cloud as a self-driving, self-securing, self-repairing service. And this is really the simplest database for developing, running any apps or analytics at any scale. So you can run just a simple developer on this, or you can run a worldwide stock exchange on this, or an e-commerce system. So that's the simple. OK, now what is converged database? It's not a new product. Sometimes when we talk about converged database, it's really a concept, not a product. What converged database is the Oracle database that we've been evolving over decades, and we've put thousands of engineers to work year after year to meet the needs of modern apps, all these things that we talked about. One thing that sometimes people get confused about is all this is incorporated in the Oracle database today in 19c, and it's all available for free. If you're running Oracle database, it's all there. There's no options needed. And what this allows developers to do is to focus on innovation instead of integration. So you can add a SQL statement. For example, if you want to run a graph query, and we'll get into this, you can just run a SQL statement that does the graph query. You don't have to add another database, move the data, maintain this thing, do all that kind of stuff. So it's dramatically simpler. Now, one thing I want to finish on here is that it sounds a little bit like a monolith database, but it's actually the exact opposite. Because when you use a converged database, it gives you choice. So you choose how you want to integrate these things, how you want to develop your app. So you might say, hey, I want to use Oracle for OLTP and documents and graph, but I'll choose Kafka for microservices, or I'll choose Elastic for text search. So you get to choose at every point what you want to do and how you want to deploy it. OK, so that's the background. That's the big picture of what we're working on, the big picture of our strategy for simplifying things and making them better. Now, what I want to do is get into what we're doing in the short term. what we will be delivering this year in our next generation Oracle database called Oracle Database 23c. Now, Oracle Database 23c has hundreds of new capabilities, and I'm not going to talk about them all today. I'm going to focus specifically on developer capabilities, some breakthrough new developer capabilities. And I'm really going to talk about 5 things today. So even within developer capabilities, there's dozens and dozens of these. So I'm going to focus on these 5. One is the unification of relational and JSON. Another one is graph, how we're integrating graph into the Oracle database. Third thing is JavaScript, how we're integrating the world's most popular language into the database. Microservices and how we're making them transactional. And simple app tier caching. So those are the 5 things I'm going to talk about today for developers. So starting with the unification of JSON and relational. Now this is a big deal. I think this is an industry-changing event, this technology that we're introducing here. And all the customers and analysts that we've described this to then also agree that this is a huge deal. So I'm going to walk you through this. Okay, so first of all, let's start with an example. Suppose you're developing an app for a student schedule. So this is kind of what the app would look like. You have the student schedule for the student Jill. It's got 2 classes, Math 101 and Science 102. And in there, you have the time, room, and teacher for each class. So it's a very simple app that's being developed. How do you do this? Well, with relational databases, what you do is you create normalized tables. So for this application, you create 4 tables. You got a student table, a teacher table, a course schedule, and a table holding the courses that a student is taking. So you create these tables and you build your app. Now, in the ideal world, when you're developing this app, you want to be able to read and write the schedule from your app with a single simple database operation. And that should return all the data and allow you to update all the data. With a relational database, you can do all this stuff, but it's not as convenient. You have to read and write each of the 4 tables. So your app has to say, OK, I'm going to read the student schedule, I'm going to read the course schedule, I'm going to write this. So it gets a little more complicated to write. Now, if you store the schedule as a JSON document, things get a lot simpler. So you see on the right here what a JSON document looks like with Jill's schedule. It looks kind of like what's on the screen in the app. You have Jill at the top, that's the root, and underneath that you got her schedule, which is an array of classes with the time, course, room, and teacher of the classes. So that's what you have. And then you can simply put this schedule and get the schedule from the database. So from a developer point of view, that's quite a bit simpler to develop the app that way. Now, Oracle has had JSON integrated in the Oracle database for over a decade. And we have really the best JSON in the world. We're actually better at JSON than JSON databases. We have document native APIs like simple document access. We now have a MongoDB compatible API, so you can run Mongo applications directly against the Oracle database. The JSON format has been standardized in the SQL language, and we support all that, including things like parallel SQL that JSON databases don't have, full ACID consistency. So we have great JSON in the database. So all that sounds wonderful, but what's the problem? The problem is when JSON documents are used as the storage, then you can create data duplication issues. So you can see on here, you have these 2 students, Jill and Jack. They're both taking Science 102. And what does that mean? The JSON document that stores Jill's information and the JSON document that stores Jack's information have the exact same data for Science 102. It has the same it has the time, the room, the teacher, all that. All that information is redundantly stored in both those JSON documents. So why is that a problem? Well, this inefficient. You're repeating data. Most importantly, it's hard to update it. When you start replicating data all over the place, it's hard to update it, and it's hard to keep it consistent. Also, whenever an app is successful, you add more use cases. So a simple example here is you had student schedules. What about the teacher schedule? Well, that's kind of different from the student schedules because teachers only teach one class. It's Science 102. But what you want to know is what room it's in and what's the time. So the root here is the teacher instead of the student. But you see, a lot of the data is the same as what's in the student schedule, but not all of it. It overlaps with what's in the student schedule. So now, if I change the time for a class or the room, I got to go update all the students that are taking that class and all the teachers. So that's the issue with duplicating the data, and that's the issue that relational databases were actually invented to solve, which is you should only store one copy of the data. So we have this trade-off. JSON makes it really simple, but it brings in this new set of problems with data duplication. So what do we do with that? Well, what we ideally would like is something that combines the best of both worlds, where you can get all the benefits of JSON, that easy mapping to app operations, where you can get and put the whole thing in one operation, the agile schemaless development, the hierarchical format, the easy mapping of JSON to application classes plus all the benefits of relational. So you get that no data duplication we were just talking about, the use case flexibility. You can use the same data for multiple use cases. Queryability, of course, that SQL is famous for, and consistency that relational databases are famous for also. So what you really want is the combination of two, all the benefits of one plus all the benefits of the other. And that's what JSON document relational duality is all about. So that's what I'm going to talk about now. That's the problem that we're trying to solve. And the idea of this is to architecturally provide that use case simplicity of JSON with the multi-use case power of JSON. OK, so how does this work? Well, it's pretty straightforward. The data with JSON relational duality is stored as rows in a table. So the same 4 tables that we showed earlier, you just store the data in that. And that provides all the benefits of relational. And because we have JSON as a data type in Oracle, you can use JSON columns for data where the schema is dynamic or evolving. So you get both of those things. And then, quite simply, you can access the data, both read and write the data, as if it was a JSON document to deliver that application level simplicity. So I'm going to show you how this works. So on the right here, we have the student schedule that we're trying to show in JSON. And what we're going to do is we're going to define something called the JSON relational duality view. So it's a view on top of the tables that returns the data as if it was a JSON document and allows you to store it as if it's a JSON document. And we define this view using GraphQL syntax. So that's a syntax that's very popular now, is this kind of GraphQL language. So first of all, you say create the JSON duality view. You see the syntax there. And what you notice is the syntax of this view matches the syntax of the document that you're trying to get out. So in the document, you have the student name, the student ID, the schedule, which is the timed course ID of all the courses. And in the JSON duality view, you have the exact same tags. You have the exact same name. So it matches exactly. So it makes it very simple. Hey, you want this document? The view is defined exactly the same. What's missing here is you have to say, OK, that's the output I want. Where is it coming from? Well, you tell it what tables each of these values is coming from. So in this case, the student information, it's coming from the student table. The student courses information is coming from the student courses table. So you add the table name to say, where is this data coming from? And then you add the columns. So for example, the student information, what's the column that data is coming from? And now you have the entirety of the view. So this is the definition of the view. You just tell it, what do you want as your JSON document? What tables is it coming from? What values are you getting? And you're done. So it's super simple to define these views. So you say, create this JSON duality view called student schedule. Once you've created this view, you can use it. So what does that mean? You can read the data using REST as if it was a JSON document. It is a JSON document. So the example here, you can run a REST get operation against this duality view. You give it the URL. You give it the name that you want. This is Jill's schedule. And it will return to you as a JSON document. Also, you can put the data back. So it's very simple to write the data using REST. So after you get the data, you can basically edit it in your app any way you want. You edit the document, and then you just put it back into the database. And what the database will automatically do is look and see what you changed in that document and automatically do all the updates, inserts, and deletes to the underlying tables. So from a developer point of view, you're just dealing with this student schedule document, the Jill document. You get it, you edit it, you put it. And the database does everything necessary to make it, to normalize it and make it relational. And by doing that, if you have other views that select the same data, they automatically get every update. You don't have to worry about updating every other place that has the thing, keeping it consistent, data duplication, all that kind of stuff. It's all taken care of. So that's kind of the idea. It's very simple. Now, it's a little bit like object relational mapping. So you're taking tables and mapping them into JSON documents, but it's much more simple and powerful. So if you have an object relational mapping layer, that sits kind of in the application tier and kind of interprets, the APIs as they go across. This is something that's natively built into the database. It's declared as a view. And that means that the mappings from tables to JSON is centralized in the database, and it's language independent. So this will work from any language, whether it's JavaScript or Go or C or anything you want. It doesn't matter. So it's completely language independent. The database understands this JSON view, these application objects defined in JSON and using these views, and you can run JSON queries against them. So powerful JSON queries. I talked about you can get and put all the use case data. So that API for that Jill schedule, you just say get me Jill schedule, put Jill schedule. It's very simple. And it allows you to hide the underlying table schema, which is something a lot of people want. And it's declarative. It follows the philosophy of SQL, which is don't tell me what to do. Oh, I'm sorry, tell me what you want, not how to do it. So you declare the view, that's all you got to do. We automatically allow all these operations on top of the view. Also, and I don't have a lot of time to get into it, but there's a very interesting new lock-free concurrency control that we've built into the database for JSON duality. And the reason we did that is because protocols like REST are stateless. You do an operation, you do another operation. There's no state in the database between these operations. So normally you need transactional state, session state, all that in the database. So with this lock-free concurrency control, we enable REST calls that are completely stateless. And these are great for interactive applications since data isn't locked while humans are thinking about it. Also, this lock-free concurrency control gives you document level, think about it as document level locking that works with SQL row level operations. So it's completely seamless. So you never have a problem where you're updating a document and somebody updates the row underneath you and it conflicts. So you never have those kind of issues. So again, I don't have time to go into this, but it's a very interesting and novel new transactional mechanism that we built into the database to make this simple. Okay, so now you get the best of both worlds. So developers can store data as relational and access it as relational. That's the traditional relational model. You can also access it as a JSON document. You can get and put it as a JSON document. That's what duality views do. And this is great when the data schema is known. Relational is great if you know the data schema. If you're not sure about the data schema or it's evolving, then you can just store the data as a document directly in the database. And this is great for, like I said, dynamic or evolving schemas. You can access that as relational using something we call JSON Data Guide, or access it as document using standard JSON APIs like SOTA or MongoDB API. So all that works. And MongoDB API will also work against the JSON duality views. So that's kind of the big idea of this thing is documents and relational are fully unified. So you get all the benefits of relational plus all the benefits of JSON in one product, in one solution. And again, this is something we started talking about a few months ago, and we have tremendous interest in this. I mean, the industry analysts, the database industry analysts have gotten we've gotten amazing quotes from them. Here's one from Wikibon saying it ends the long-running relational versus document debate, providing the best of both worlds. Here's another one from IDC. It brings simplicity and flexibility to modern app dev. No other database offers this revolutionary solution. I think this is going to change the industry. I think this technology is going to be adopted widely throughout relational databases. And it's really going to simplify application development. OK, so that's a big thing. That's the first thing I wanted to talk about. Let's talk about something else that's very current, which is graph technology, operational property graphs. All right, so connections between entities are all over the place, right? So social networks are all about connections. Bank transactions, you transfer to A transfers to B transfers to C. Transportation networks, supply chain networks, interactions between things and people. So graphs are all over the place. And there's a lot of interest in graph technology. The idea of graphs is to make it simple to get value from connections between data. Okay? Now, relational databases have something called a join. A join basically allows you to connect different kinds of data. So you can for example, when you find all the order lines for an order, that's connecting an order data with order line data. And the relational lets you do that very simply. That's the traditional stuff with relational. Or an example I'm going to use here is, let's talk about bank transfers. So let's say I have a bank account. And it's a very simple schema. Every bank account has an ID and a balance. And you have another table that says bank transfers. That says, hey, I transferred money from bank account B to bank account E, and it was $1,050 that I transferred. So that's a very simple schema, right? So if you want to find money transfers directly from B to E, you just write that query on the right. It's a simple join. Everybody knows how to do this. Now, what's the problem with relational? The problem is that's all fine when there's one connection, right? When you're looking at one bank transfer. So, but what if I want to find bank transfers that occurred between B and E that went through two other intermediate accounts, okay? So it's not just a one-hop transfer. It's a hop that went through three accounts. How do I do that in SQL? Well, you can do that in SQL. You just have to write a lot of joins because you're joining all these intermediate accounts in. So the thing on the right is how you would do this. It takes basically for a two intermediate accounts, you need 12 joins and 3 unions to get the answer, right? To walk all the possible paths there. So that's how you would do it in relational. So it's possible to do kind of this graph queries in SQL, but it's pretty painful. And as you add more hops, of course, it gets more complicated. You have to add more joins and more unions. So it's not a lot of fun. So that's where graph technology comes in. So the idea of graph technologies is you think of data as vertices and edges. So this bank account that I showed you is vertex. So each account, think of it as a vertex in a graph. And the transfer is the edges between vertexes, right? So when you transfer from account B to account E, you have the two accounts as vertexes and the transfer as an edge. And each of these can have properties associated. That's the terminology they use in graph, properties. We think of those as columns, as values. So like bank account B, it has ID B and balance 2,000. Those are its properties. And the transfer, the edges, also have properties. So in this case, it's how much money got transferred between B and E. It's $1,050. So this is kind of the graph model. It's the same data, but you're thinking of it in a different way as vertexes and edges. And now you can write queries against vertexes and edges. Okay, so graph capabilities, this is something that Oracle's been doing for a lot of years. We've actually had graph capabilities incorporated in Oracle database for many, many years. And we use a language called PGQL, which is a SQL-like query language that's open source. And it's been in Oracle. We have 60 built-in graph algorithms that do a lot of things that you do with graphs, like community detection, evaluation of structure, ranking and walking, et cetera. What's new in our new database is that graph query language has been standardized. So the SQL standard now includes something called SQL PGQ, which is a little different from PGQL. That's been incorporated in the SQL standard, and Oracle's implemented this SQL PGQ language directly in the Oracle database. And the way this works is you create a property graph view on existing relational data or JSON data, and it works against the underlying tables. And I'm going to give you an example in a minute. So the idea here is you don't have to separate, you don't have to create new data structures or new databases or anything else. You just define a view on top of your existing data. And so it integrates seamlessly with the existing relational, and it runs against OLTP data, and it's fully transactional because it's actually operating on the underlying relational data. Okay, now let's talk about what this can do. A good example here is, suppose you have this graph of people transferring data, and you want to find out, did somebody in account B transfer money to account E in through 3 or fewer intermediate hops. So that's the kind of the dark lines on there. So that's the query that we want to run. Okay. So this is how you do it. So this is how you do it now in Oracle Database 23c. first of all, you define this view of the graph on top of the relational data. And when you define the view, you say, create this property graph. You give it a name, in this case, bank graph. And you tell it the tables that hold the vertexes. So remember, that table was called bank accounts. So you say, hey, the vertexes are bank accounts. And the properties that I want out of that are the ID of the bank account and the balance in the bank account. And then you define the edges for that property graph. So again, you got the edge tables. And that edge table was the bank transfers table. That's where the data is. And you tell it, it's an arrow between the two things. So you tell it the from and the to, right? And the from and the to happen to be the same, which is the account table, but they're different values. And then you tell it the properties on that arrow, on the edge, which is you want the amount that's being transferred and the account that it's being transferred to. So that's it. Now we've defined this view on top of the relational table. And now we can use this new graph query language to query this view. So how do I do that? So again, I just do a regular select statement. And I'm going to say from this graph table. And remember, the name that we gave that view was bank graph. So I named that thing. And then I add this new clause that didn't exist before called match. So what I'm going to do is I'm going to match a pattern of vertexes and edges. Okay? So I'm going to match. I'm going to start with vertex 1 and vertex 2. The way this is denoted in the syntax is they have parens around them. So you got v1 in parens and v2 in parens. And I'm saying, hey, I'm trying to find transfers from B to E. So I put that in the where clause. I say where the vertex 1, the source is B, the end vertex is E. Okay? And then what I say is, what are the edges that I'm looking at? So E is the edges between the two vertexes. And then I tell it how many hops. So what this says, that 1, 3, is it says, hey, I'm looking for transfers that occurred between 1 and 3 hops between bank B and bank E. So now I've written this query, and then finally I tell it, what is the output that I want out of this query? In this case, that list tag says, hey, take all those intermediate accounts and put them in a string for me and return that. So I want the path that it took to go from B to E. That's what I'm returning. And that's it. That's your whole query. So the thing that took 12 joins and 3 unions before, I just did in 6 lines of SQL. Okay? And if I want to go 5 hops, I just change that number 3 from 1 to 3. I just change that to 5. I don't have to write another 30 joins. Right? So it's dramatically simpler. That's what the graph language gives you. It's a dramatically simpler way of walking these connections, these vertexes and edges, and producing a useful result. And that's been now built into the Oracle database. So that's what the graph standard SQL PGQ language is all about. All right. So that's the second thing. Now let's move on to the next thing, JavaScript. So JavaScript is now the world's most popular language. And what we've done in Oracle Database 23c is we built JavaScript directly into the database engine. So you can write stored procedures in JavaScript. So up to now, you've been able to write stored procedures in PL SQL and in Java. Now we're writing JavaScript. We're implementing JavaScript as a first-class language in the Oracle database for writing stored procedures. And why? Because JavaScript is useful, but also it serves the same purpose that JavaScript serves in the app. People put JavaScript in the client because it reduces the round trips. It does logic in the client that will reduce the number of round trips you need to do to the server. It's the same thing. If you write stored procedures in the server, it reduces the number of round trips to the database that you need to do to implement an app. It's much simpler. It uses the exact same language you're using in the client. We've implemented it using our Graal VM, which many of you know about. It's very widely used in the Java and other communities because it's a multilingual VM that does just-in-time compilation, extremely fast and low overhead. So that's all implemented now directly in the Oracle database in Database 23c, the world's most popular language. Okay, let's move on to the next thing, transactional microservices. So microservice is a big deal. Everybody knows developers are writing everything using microservices now. And what's a microservice? Very simply, it's you're building your app as loosely coupled services that are connected using asynchronous events. And these events are published on event platforms like Kafka. okay? Now, what's the issue that we have is preserving data consistency across microservices is hard, right? Why? Because there's things like process and network failures, concurrent changes, you can restore stuff from backup, you can have disaster failovers. It's hard to keep the data consistent in the presence of all these failures. Now, this is not a new problem. This problem has existed from the beginning of time, and there's a solution for that. It's called transactions, right? And if you go back, a few years, we had a similar situation where we had NoSQL databases that came in and said, hey, you don't need transactions. You can just do it all yourself in the app. You don't need this ACID transaction. Now, over time, people discovered, well, that's not such a good idea. It turns out it complicates the apps, and it becomes very difficult to do. And so almost every NoSQL engine now has transactions of some sort implemented in it, because this claim that you don't need transactions, it just isn't true. Transactions make development much more easier and makes the apps much more robust. And we think the same thing is going to happen with these event services. Now, Kafka has started building transactions into the event platform, but it's only inside the event platform. So you get transactions kind of when you're moving things within the event platform. But when an event goes to the database, you lose transactional consistency. And that's where our transactional event queues come in. So the Oracle database has supported kind of queuing technologies for decades. So we've had this thing called AQ. It's very widely used by thousands and thousands of applications. E-Business Suite, everybody uses AQ. And we've evolved this over the years, and now it's called transactional event queue in the database. Now, how is this different? Well, it's transactional. So you can publish and consume events, and that publish and consume of the event is transactionally integrated with database changes. So either it all happens in one shot, or it doesn't happen at all. It also handles complex cases that are hard to deal with in generic events, like events that change the database state and produce more events that then have to be integrated with the previous event. It also provides the exactly once semantics, not at least once, but exactly once, without having to deal with two-phase commit or idempotency. And it's fully integrated, so things like security, backup, recovery, et cetera, it's completely integrated with the database. So you don't have to integrate these two systems. And over the years, we've turned AQ into a scale-out architecture that can process over 1 million events per second. So this exists today in the Oracle database. And you can access these through any app. So we have support for REST APIs now, JMS, Java, Python, Node, C, C++, C#, PL/SQL, CLI, everything under the sun. And events can be transactionally propagated between databases. So it's not just in one database. You can set these events to propagate to a different database for a different microservice, let's say. And so what we're coming out with recently is integration with Kafka. So we integrate the event model in the database with the Kafka event model. For example, we can automatically propagate events that are put into Kafka into transactional event queues in the database, and do that in a transactional manner, and then we execute them in the database as a transaction. And we also now support a Kafka-compatible Java and REST API. So transactional event queues had their own APIs. What we're doing now is we're saying, hey, you can take your Kafka APIs and run them against transactional event queues in the database. So for example, on the left here is how you would write an event into Kafka, right? And part of that is, you specify the Kafka library and the Kafka endpoint to put an event into Kafka. Well, we've implemented the exact same thing. So you can take that exact same code, and now all you have to do is change the library and the endpoint, and it will send the event to transactional event queues instead. So we've made it very compatible. That's making it seamlessly compatible with Kafka. So we get transactional events, seamlessly compatible, same API as Kafka. You don't hardly have to do anything to get a much more robust system. Or you can put it in Kafka, and we'll automatically transfer it into transactional event queues. So we're trying to integrate with generic stuff and make it much better by adding transactions. OK. And then I think the last thing I'm talking about today is application tier caching. That's something we're calling TrueCache. So again, this is a new feature we're going to be releasing with Oracle Database 23c. So what's the idea here? So a lot of people are implementing mid-tier caches for high-end applications. And so the idea is you put this cache in the middle tier, and the idea of it is it's supposed to improve the application response time and reduce the load on the back-end databases. Now, what's the problem with this, right? The problem is mid-tier caches today are not actually caches. They're application developer maintained inconsistent database subsets. So if you take something like Redis and you put that in the mid-tier, that's not a cache. It's something that each application developer has to store data into, get data out of, maintain the consistency, age it out, manage the whole thing. And the analogy I use, it's kind of like calling these things a cache is kind of like calling a file system a database, right? It's like, yeah, you can store data and get data, it's a database. You just got to implement everything on top of that, all the consistency, all the APIs, everything. It's up to you, the application developer, to implement that, right? Well, it's not a cache. A file system is not a database, and systems like Redis are not a cache. A cache is something that works transparently to the application that you don't have to write your application around. So Oracle TrueCache, what this actually is a lightweight, essentially diskless. It just has some metadata on disk, but it's essentially a diskless Oracle database instance that's deployed as a cache. So you deploy this, for example, in your mid-tier. And once you've done that, then you can direct any SQL query to that cache instead of to the backend database. So it is a full function cache. It runs full SQL. You can have JSON in there. The JSON duality views, all that stuff that I've talked about is automatically implemented. So anything you can do to the database, you can direct to the cache, and it just works. So the way this works is, in the cache, you run the query over there, and if the data is not in the cache, then the cache will automatically fetch it from the backend database and cache it in the front-end cache. That's what a cache does. It says, hey, I got a cache miss. I go to the actual data. I bring it in. Now it's in the cache. Now the subsequent references hit it in the cache. It's very simple. The other part of it is, what happens if somebody changes some data on the backend database? Well, when you're manually maintaining Redis, it's like you have no idea somebody's changing something in the backend database. With TrueCache, the database in real time propagates any changes to the database up to the cache. So the cache is kept consistent in real time. Also, when you query the cache, everything you see in the cache is consistent as of a point in time. So you don't see record 1 as of 2 o'clock, record 2 as of 2:01, and record 3 as of 1 o'clock, where you go back and forth in time, where it makes the application very difficult and very buggy. You get everything at a consistent point in time. So that's why we call this TrueCache. It's not a faux cache. It's not something that I pretend is a cache, I write it all myself, I implement everything, and it's completely inconsistent. It's something you can drop into an application, run arbitrary SQL, the consistency is maintained, it automatically loads the data. You don't have to do anything. All you have to do is point your queries over there. Okay? What are the use cases for this? Well, I talked about mid-tier. You can just put it in your mid-tiers, and it caches data. But there's a number of other use cases. You can use it as an edge cache. So for example, if your database is in the cloud and part of your application is on-prem, you can deploy TrueCache on-prem so you don't have the latency of going all the way to the cloud. Cross-region. So if your database is in the United States, but some of your app is in Europe, you can deploy the TrueCache in Europe, and you avoid that latency of going across regions. And cross-cloud cache. So multi-cloud is a big deal. So for example, you can have your application in Azure and your database in Oracle Cloud. Well, the latency is going to be a little longer than within the cloud. So you deploy TrueCache in Azure next to your application, and you eliminate that extra latency. And it all happens very automatically, transparently, consistently, all that. So huge benefit over a manually maintained by every app and every app developer so-called cache. All right. So that's what I wanted to cover today. The key takeaways from what I'm talking about. Number one, we've unified JSON and relational. This is really, this is a big deal. So you're going to remember years from now, it's like, hey, I was at that talk where Juan said, hey, we've unified these things. This is going to change the industry. This isn't just an Oracle thing. This is going to change the industry. Number two, data as graphs. So we've allowed, with standard SQL now, to create graph views over relational data. So you can run graph queries as simply as running a normal query without having redundant data. It's all super simple. Just create the view, query the view. Number 3, JavaScript, the world's most popular language, now embedded in the Oracle database as a native stored procedure language, extremely fast, extremely simple to use. Number 3, transactional microservice. So we're moving the world from a transaction-free, brittle world to a transactional microservice world. And number 4, this app tier caching that supposedly people have, but has never really existed, because a cache is supposed to be transparent. It's not something that every developer is supposed to manage. So those are the 5 things I'm talking. There's a lot more developer things, and if you go to the other sessions today, you're going to hear about many more things that we're doing in Oracle Database for simplifying application development. But those are the ones that I think are real highlights that I wanted to talk about today. Okay, so you will be able to download Oracle Database 23c starting next month for free. So we had a version of Oracle called Oracle XE, which is a free Oracle database version. We're going to be producing one for Database 23c called Oracle Database 23c Free, and you'll be able to download that next month from oracle.com/downloads. And you'll be able to try all these features that I talked about today. Okay, I think I'm out of time. These guys are saying to wrap up. So thanks a lot. There's a lot of very interesting sessions you can attend today that go into a lot of drill downs and other topics. So please join all these sessions. And thank you for coming today. And thank you for joining us online also.